Hey, good afternoon, everyone. My name is Nati Swaminathan. I'm a senior solutions architect with AWS. I've been with AWS for close to 3 years now, and I'm joined with Sri here, my colleague. Sri, you want to just introduce yourself?
Yeah, sure. Thank you so much, Natty. Yeah. Hey, I'm Sri Godavalli. Actually, I'm a serious solutions architect in AWS as well. I've been with AWS for almost 2 years now. We both cover networking as our subject matter experts in AWS. So today's session is going to cover like how you can implement hybrid global network, with AWS and like what all services, features, and things are available for us. Good, Natty.
Yeah, thank you, Sri. Yeah, so the first thing I wanted to talk about is, the AWS's global network, right? You would ask, why is that important, right? AWS, has a global cloud infrastructure, and that is secure, extensive, and a reliable platform. And we have more than 200 different services, right? And we want to give customers the same experience no matter where they stand the infrastructure. So that's why having a global network is very, very important. And all the cables and things like that, AWS manages it end to end. We don't lease it or do anything of that. So it's our data center, AWS's data center that we manage. Just wanted to talk a little bit about the global infrastructure footprint that AWS has. So basically, to support a global network, right, we have about 33 geographic regions. So the slide is a little outdated there. So right now we have 33 geographical regions and like about 105 availability zones across various geographies in the world, right? And basically this is important because you can replicate your infrastructure anywhere in the world in minutes, right? Like you don't have to worry about the different places that you're going into. Getting the same AWS infrastructure no matter where you go. And the data stays in region until and unless you decide to move it. This is important, especially if you're doing business in Germany, right? Which have like strict laws of exporting data from the country. Now let's talk a little bit about, okay, we have a good global infrastructure. How do we connect to AWS, right? There are quite a few methods that you can use to connect to AWS. The first one I want to talk about is site-to-site VPN. So site-to-site VPN is a very common technology that's been used. Like people in on-premise world, use VPN. It is the same thing. There is no magic about it. So the idea is you would have an on-premises router. From there, you would connect into virtual private gateway, which is an AWS terminology, establish a VPN tunnel, and then basically you can send data across that VPN tunnel, which is encrypted. The current throughput we support on a tunnel is 1.25 gigabits per second. There is another construct here which is missing in the slide, which is called as an AWS Transit Gateway. You can also terminate your VPN tunnel on an AWS Transit Gateway. And if you did that, you can double your throughput. You can get about 2.5 gig of throughput per tunnel. So that's AWS site-to-site VPN. And if you wanted to, if you want, like, for example, more reliable connectivity on the VPN, like internet, can be unreliable at times. So if you wanted, like, more reliable VPN connected, we have an option called as, accelerated site-to-site VPN. So the idea is from your ISP, wherever your ISP is, right? Like we will bring you to the closest POP where AWS presence is there. And from there, we will let you write the AWS backbone for a faster connectivity. So you can leverage AWS accelerated site-to-site VPN if you want like more less latency and like a predictable performance. And then the other method is AWS Direct Connect. So AWS Direct Connect is a dedicated connection, right, between your location, your data center, and AWS. This is a private connection, and it is basically you get like there is no. It is a very reliable connection. You get speeds and feeds like up to 100 gigabits per second, right? And unlike the internet, you have SLAs and those kind of things. So it's more reliable. And the idea is, again, from your on-premises data center, you would connect to a customer router, which is in a colo. We have like hundreds of POPs across the country, across the world. From there, you connect into the AWS router, and from there, you basically get connectivity into the AWS region. So just letting the slide build out. So a couple of things. We use eBGP, which is a standards-based routing protocol that is available to route packets between your network and AWS. We also support MACsec, which is a layer 2 encryption methodology, which gives you like line rate without getting the penalty of like IPsec VPN, where your throughput is considerably decreased. So MACsec gives you line rate encryption. So we also offer that support. If, for example, right, like you don't have a presence in a CoLocation, then what, right? So you can use a direct connect partner, and you can have their L2 circuit from a partner to basically extend your data center into the AWS router. And there is another type of connectivity that is available with Direct Connect called the hosted connection, right? So the idea behind the hosted connection is, if you don't want to manage your infrastructure in the colo, if you want like a third party such as an AWS partner to manage it, so we have like colo locations where the partners would have a partner router, and from there they would connect to the AT&T, they connect to the AWS network, right? The partners are like AT&T, Verizon. There are like several partners, right? Those are the usual famous ones, right? And with the DX connection, you get like speeds from 50 megabits until 10 gigabits per second. So you get like sub rates as well. So just wanted to show another slide which gives you differences between the dedicated connection and the hosted connection. I'm not going to go over the entire slide, just in the interest of time. Wanted to highlight a couple of important things. So we have increased the limits. So now if you have a dedicated connection, you can get up to 4 transit WIFs to use to connect to the transit gateway. And the other thing you want to be sure, I want to bring it up is, right, like if you had a dedicated connection and if you're in a time crunch, it takes longer to set up. However, the hosted connection is quicker to set up because the partners usually have everything ready. With
All
that,
right.
I wanted to hand it over to Sri. Thank you, Sri.
Yeah, thank you so much, actually, Natty. I mean, so far, actually, whatever we have covered in this particular session, but Natty was covering actually is related to the AWS region, right? That means we have a specific region like US East 1 or US West 2, which is Oregon. How do you connect into that particular footprint? But there might be quite a lot of other use cases which are related to the edge, right? I mean, if your application requires a very low latency connectivity, and I mean, and they have a mechanism where like you don't want to have, I mean, you have workloads that are denied, distributed, interrupted, or limited access applications. I mean, those require, I mean, like a high level of low latency responses, right? So the second use case actually I want to cover here is local data processing. If there is a customer who manages like intensive data workloads actually within their on premises, like connected vehicles or like any other real-time IoT device processing or anything like that, you need that local data processing for it. And also the third edge case actually that that I want to bring up here that AWS covers is like data residency part, right? Earlier that you mentioned that Germany, you have to keep the data there. As an example, I'm going to use one of the customers that we have, FanDuel, right? Due to compliance and national sovereignty requirements, I mean, you have to keep the data of users within the footprint of that country itself. So for that edge data residency, we have some applications and products that we support, I mean, in the AWS with the same footprint of the region and experience that you have, right? So the last one is like migration and modernization. Earlier, we covered a session for migration and modernization. In certain scenarios where you want to migrate like huge amount of workloads that you have like petabytes and petabytes of data that you want to move from on-premises into the cloud, I mean, sometimes the reliable networks doesn't actually scale up to the scale of the data that you have. So we have some applications and services in AWS that would allow you to move the data from your on-premise to the cloud or vice versa if you want to move it back to your on-premises as well. All this can be achieved with the same experience that you are leveraging today within an AWS region with our API streaming services, the security, and the usability of the services with the scalability that we have within the region, right? So in the next slide, what I'm going to cover is, some of the infrastructure elements and the services that fall into this particular edge scenarios. First one is AWS regions, we already covered, which is global infrastructure. Our primary regions like US East 1, US East 2, US West 2. Like that, we have about 33 geographic locations right now today, what we call them as regions deployed. And if we want to extend the workloads to the low latency scenario, like there is something called AWS CloudFront. AWS CloudFront actually, I'm sorry. AWS CloudFront has like highly distributed scalable network for your like API dynamic content provisioning like Amazon Prime or Netflix. So there are low latencies applications that can provide this kind of service will be like our AWS CloudFront. We have about almost 450 point of presences and like 90 plus cities coverage wise, to provide you with this distribution, edge distribution service, which is like AWS CloudFront. The second one I want to touch base, not globally known or not a whole lot of people know, is like AWS local zones. Like a high density areas, we bring, our compute storage database and other AWS services to a largely populated or industrial centers where you require like low latency processing or media center, or even like for the content creation, right? Some of the customers that leverage this particular infrastructure is, gaming industry people who actually host the same, same applications with this particular local zone as well. You can find the same services within the local region, the same compute database and content distribution services as well. Right? And you would be leveraging the same tools as AWS tools that you use on the region and the APIs. We have about 32 local zones as of today, 15 in US and 15 outside of US and 17 within the US. And there are 21 metro areas across 18 countries that we have covered. In the next slide, I'm going to show a high-level view of what those are. The next one I want to quickly touch base is like AWS Wavelength. This is basically providing you with the AWS compute and storage services at the edge of the 5G mobile network, phone services, right? This will enable you to actually deploy applications with like close to sub-milliseconds, which is like 10 milliseconds latency serving to your mobile devices as well. This is an extension service found, in an AWS region, and it'll be available like all the way to the mobile edge services as well. AR, VR, gaming, live video streaming, machine learning, like all these are like use cases to actually leverage it on the 5G wavelength scenario. AWS Telco Network Builder is more focused towards the CSPs that watch service providers, telecom service providers that want to deploy automatically the telecom specs onto the cloud provider, cloud service provider infrastructure. AWS has a cloud telco network builder application as well that would allow you to deploy telco networks on the AWS footprint as well. So this will cover the metro area and telco networks. Now coming to the on-premises, if you want to leverage the same exact API security tooling and like infrastructure as a code deployment and everything, we have a rack or a server-based service called AWS Outpost. You can get like a couple of single rack servers, or like you can get an entire rack. This will give you the same interface, API, and usability toolset to control it from your AWS console and deploy the applications on this one seamlessly like you're doing within a region as well. For the services, for container services or microservices, we have EKS and ECS anywhere as well, which will be deployed on top of the Outpost. Similarly, we have a private 5G service available where you can deploy your 5G networks on the AWS edge scenarios. Also integrated private wireless on the AWS where like you have a large industrial area or something like that where you want to deploy 5G cellular networks, you can actually leverage this particular service to deploy. Last two that I want to cover in a single bundle here, what we have is an AWS No family, which is typically used for these, interrupted service, store forward kind of scenarios. It provides you with the compute and storage mechanisms to send the data whenever it connects to the location. And also you will have compute and storage services available there as well. Last but not least, IoT services. We have certain IoT smart industry connected car tool set that will allow you to actually address some of the low latency, quick, highly computational services available for you at the edge devices. Of all these, actually, I want to touch base today because of the time constraints. Two specific services I want to call out is like AWS local zones and also AWS Outpost. That seems to be predominantly like a lot of customers leveraging these days, but rest of the use cases also suffice for us. If we have another session, I will cover those coming in there. Just to give the local zone footprint that I talked about earlier, within America, there are like 17 locations. Outside of America, there are US, there are about 15 services, 15 high density populated areas where we have the local zone services. Just to give you an architectural construct of how a local zone works is nothing but actually, if you have a specific region, in this example, I'm taking US West 2 is the parent region that I have. You have virtual private cloud, which is a boundary construct on the AWS for a specific network element that you deploy your host and everything within that particular region or virtual private cloud. There are multiple availability zones available within the each region as well. So you can deploy your subnets network, everything siloed up for the high availability regions or availability zones. And local zone is an extension tied up to its parents region. So you can deploy the same network elements like the route table, security group, network access list, direct connect gateways, VPN gateways, internet gateways, everything deployed within the local zone as well. So you can architect like highly available solution with low latency services to your customers that are actually in the edge. In this scenario, the high density population will come to the local zone. In case of local zone failure or some issues happen with that particular local zone, they could leverage the AWS region where it is until the local zone is being restored or recovered. There are some network constructs that can be extrapolated from this one. If you want to build multiple local zones, like as an example, Dallas and Atlanta are two local zones where you want to use. You can build an architecture, those two being your availability zones, and connect to a parent region and have the traffic flow between them as well. The other service that I want to focus here is AWS Outpost. It provides you with your compute and storage to run. It can also orchestrate containers with ECS and EKS anywhere. It gives you the same network elements that you have on the region, which is VPC, VPC, and the same constructs of security groups, access list, and like even the IAM authentication for the security as well. It will also run some of the IoT and AI/ML workloads as well on the Outpost servers, which is called AWS IoT Greengrass. Just to look at, right, how does the actual Outpost work, right? I mean, the Outpost service allows you pretty much actually to deploy your application on the Outpost itself. I mean, it is a logical construct, right? As those outposts are outposts are the rack. I mean, just like the region, you'll handle the underlying hardware. AWS will handle the underlying hardware, hypervisor patching, security patching, and everything. You just deploy the applications on top of it and use it, right? Each server, in this particular architecture, it could be a rack or a server, will have an outpost ID, and it will act as if its own perimeter boundary. So you can build the same constructs where you can deploy this to hundreds, if not like thousands of the sites across the region. And you can tag the services, and you can deploy these services using the CloudFormation automation provisioning that we have, or Terraform, or any of the infrastructure as a code elements that we have to deploy it and have it connected seamlessly without having to redo everything, which is different for your on-premises versus actually in the AWS cloud. That being said, I know I have spoken a lot here. I just want to thank you for this opportunity, Ron. And if you guys have any further questions, or if you want to do any other deep dives on this particular components on the edge or network elements, we are here to come back and deliver a couple more sessions.